Hi, I'm Douglas Gorlai. I'm joined today by Ken Duda, our CTO and founder. Arista is now entering the third phase of our evolution of the EOS stack architecture. We'd started with our system database, a centralized device-level state architecture. We've now evolved to the network database, where we're bringing together the state from multiple devices together into a common architecture. And today, we're introducing the network data lake, the third phase and extension of the EOS stack architecture. This intersects with the third phase of our networking industry's evolution we've seen overall, where we've gone from switching and routing architectures and federated systems, evolving to SDN and centralized programmable models. That evolution moving forward as an industry towards artificial intelligence and machine learning. Where these two intersect is the enablement of data. We are gathering not just networking data, but the networking state, enrichment data from all the systems around it, digital experience monitoring data, third-party data into a common, multimodal, multi-tenant data lake architecture. This enables a broad ecosystem of partners to interact on top of this data and create significant value for our clients, and becomes the foundation for applying AI and ML technologies intelligently to solve real-world customer problems. The type of customer problems this solves are a look back and predict forward modeling, where we can look at what's actually happened and then use that data to create supervised learning models with full explicability to model that which will happen on the network with specific changes. I'm now joined by Ken Duda, who's going to go into some of the technical architecture and detail of how we're constructing the EOS network data lake and what you can expect from Arista moving forward. Ken?
Hey, thanks, Doug. And thank you all for joining. I'm really excited to talk about this next step in Arista's evolution, because this is really the third step in a multi-year journey. That journey started very early in our company with SysDB, our system database. And this was a revolutionary idea that if we put all of the state into one common state store, we could build dramatically more reliable network software because processes can restart statefully. And this was a big success. And then we realized 8 years later that we could take all of that state from SysDB and bring it up into a common network-wide database. That's what we did in 2016 with NetDB, a network-wide data store with a time series of every state change in every device in the network, enabling a whole set of groundbreaking centralized management features. And today I'm very excited to talk about the next step of this journey, which is NetDL, a network data lake. What distinguishes a data lake from just a database is the integration of so many different sources of data and different modalities of ingesting, storing, and querying that data. NetDL is a whole array of open source technologies, all unified in a common customer multi-tenancy architecture, a common operational infrastructure, and a common scale-out model. So to be more specific, where with NetDB, we take state from switches and store it in HBase. With NetDL, we take state from all throughout your infrastructure, from switches, from network sources of truth like Netbox, your DNS infrastructure, from SFlow collectors, and we get flow data and flow samples in there, from application level structures like Kubernetes. We can then bring in data from these systems and use that data to enrich and contextualize the other information of what's going on in your network. So for example, if we've captured some packets that have a certain IP address, by enriching that with DNS, we get host names. By enriching it with application information, like your Kubernetes controller, we now know which pod it was, which application, which deployment was responsible for that traffic. And we can present that information all unified together. But more importantly still, this data lake of the different types of data provide the foundation for AI and machine learning, a state foundation without which AI and ML are just buzzwords, because you cannot learn without having access to all that data, and Arista is best positioned in the industry to bring all of this data into one common architecture. This multimodal data lake architecture is key to providing the rich application functionality of NetDL. So now that we understand the basic state architecture, Let's talk about the kinds of applications we can build on top of this. With the proper state foundation, we can train our AI/ML models and produce autonomous virtual assistants, or AVA, which are mechanisms that can monitor what's going on in your network and alert you to unusual activity, things that might be a security threat, things that might be a performance problem, or things that might indicate that a failure may be coming, that there are conditions building that might lead to problems soon down the line. We also support an API layer for uniform access to the data lake so that we can provide third-party application support so that people other than us can come up with good ways of using this data to give you operational insight, to automate your processes, or to connect to other sort of third-party infrastructure management systems, such as, for example, ticket management or incident response. Further, this same state architecture supports CloudVision, CVP, our CloudVision portal features that you're probably already familiar with. They're built on exactly the same data lake and the same set of APIs.
So, in summary and in closing here, the evolution of SDN and intent towards AI and machine learning requires the gathering of rich data from multiple sources into one place for consistency. The storage of that data in time series allows network and networked applications to be deployed and validated in a very frictionless model. What we're building today at Arista is the foundation for networking's future. Thank you.